So this is just a quick update of the problems that I was having on the in the last video with the transmit mixer and stability at the measured at the Q5 buffer fed on the output side of the transmit mixer. So I've been able to rectify that. Just to go through some of my troubleshooting process. I did sort of check all across the board to make sure there were no invalid solder connections. I checked on the reverse of the board, looked the same there. I did try sort of resoldering all the connections on the band module as well, all to no avail. And then I just looked at the the FET that I put in at the output of the premix oscillator, and noticed that the schematic called for, and so this is just here, so the schematic had called for a 2N4416, and I'd actually put a J310 there. So not quite sure why I made that mistake, but basically as soon as I replaced this FET here, everything, all the signal cleared up, and now I have a completely clear signal right across the 20 meter band from 14 up to 14.134. So let me just pan up here onto the oscilloscope and just show you this. So again, this is measured at the source of Q5, which is that buffer fed on the output side of the transmit mixer. And as you can see, as I move across the band, that's just a rock solid sine wave there. So kind of very happy with that. The other good thing is, from this is in DC mode. This is the voltage that'll be presenting to the base of the first transistor in the PA, the 2N2222, and that's more than enough to turn that transistor on. So the signal is good. There's enough there to drive that transistor. So I think we're all good to proceed to the next step, which is to start work on the PA. And just panning down to that. So what I'll probably do first is just build up this part here. As I said, the initial transistor in the PA. There's a transformer here that you've got to put into circuit, a couple of resistors, a capacitor. There's a drive adjust here. That's a simple pot, 0 to 500 ohm pot. And once I've kind of built up that, I can make sure that all that is working. And then the last stage really is just the final transistor here, which is a 2N3553. There's a diode clamp here, Xeno diode clamp here, and then that goes off to the low pass filter, which is actually on the band module, and then finally the antenna. So kind of close to finishing the entirety of the circuit here, but I will take it a step at a time. Start with this transistor, then onto the final transistor, and that's where we'll take it from there. The transmit drive is now complete. I was going to build this up in stages and kind of film it separately, but I kind of got it all done in one go, so I thought I'd just show the final output. So I've got the oscilloscope hooked up to across the 50 ohm load that's on the antenna there. If I turn that on, you can hear the kind of the side tone there, and that's running at about 14.32 volts peak to peak. And as you can see, the output to the sine wave is very clean there. So let me just turn that off a bit, so that transistor, the final, does get fairly hot there. So, but just let me sort of pan down, and I'll kind of walk through the various components in the driver. I didn't do that in the last one. So the signal from the transmit mixer comes in first to this 2N222 transistor here. It then flows through this transformer, and then from the transformer across this resistor here into the base of the final transistor. And then there's a diode clamp just here. And then we go back, let me just pan back a bit through the band module, and the low pass filter is actually these two inductors on the band module and these three capacitors here. then comes back onto the board and follows a line out through the antenna here. And as you can see, I've just got a little dummy load hooked up there. So all complete now. Now the final power, there is a formula to calculate, which I'm sure probably most of you know, but I'll go through it anyway. There is a formula to calculate the power from the peak-to-peak voltage, and that's right here. So the power equals the RMS voltage squared divided by the load. The load here is 50 ohms. Now to calculate RMS, VRMS from the peak to peak, simply divide by 2, multiply by 0.707. That results in a VRMS value of 5.06. So to calculate the power, it's 5.06 squared divided by 50, or about half a watt. So the actual documentation of the kit says that you should get around 2 watts. So I'm getting a little less than I should there. There's a few things I'm going to try and do. I mean, obviously, I've already tried peaking the various bandpass filters that are in there, and sort of I've run out of peaks there. So I do have to go elsewhere, and I'll probably get to that in a follow-up video. I'll probably call it a halt at this stage. One of the things I thought I'd do before I do that is just sort of probe across the voltages at various points. In the transmit driver that might be of interest to people, perhaps troubleshooting a similar radio. So the first one I'll do, I'll move back through the, bear with me here, I've just got to move the scope probe around here. So moving back, the first place I'll probe is at the base of the final transistor. So just panning down, so probing at this point here, and just doing that. Let me do this and then do that. Now I've got the scopes in DC coupling mode at the moment. So the values down here you can see. So 3.48 volts, 44 volts peak to peak at the base of the final transistor. A maximum voltage of 1.24 and a minimum voltage of -2.2. So moving back through the circuit, I'll now probe at the collector of the 2N2222, and that's right here. And again, I have to, if someone can tell me how to set DC offset on a Siglent scope, I'd be very happy. The only way I've figured it out is to, I can't move it up and down. I have to use this auto setup. So this is at the collector of the 2N2222. You can see that's a peak to peak of 11.28, a maximum of 14.32, and a minimum of 3.12 volts. Let me just turn that off a bit. I'm worried about the transistor getting overheated. So I'll now move back to the base of that transistor just to see. This is effectively the output from the transmit mixer. So let me turn the and you can see there I'm getting peak to peak of 1.42 volts, a maximum of 2.8 volts, and a minimum of 1.04 volts. That's just goes probing at various points in the driver circuit there. Might be of interest to people doing some troubleshooting perhaps. On this note, I'll probably call it a halt. The build is complete. Obviously, I don't have it put in a box or anything like that. I may do that. I don't actually have any boxes big enough to put this in at the moment. But this has been a fun build. Like I said, I didn't really run into too many troubles in the build, except for the mistake that I made where I put a J310 instead of a 2N4416. So that was kind of my fault. A pretty simple build, honestly. Nothing difficult in the build. I guess the most difficult part is getting the parts for the kit itself. I mean, obviously this is a fairly old kit now, early 90s. That's getting on towards 30 years old now. So certainly some of the some of the components are hard to find. I mean, I think air gap capacitors are becoming hard to find. Obviously, I couldn't find the air gap capacitor that was prescribed for the kit. I couldn't even find a reference to it. So there was that. I mean, obviously the audio amplifier, they're easy to find, LM386, so you can get them everywhere really. The 4.915 megahertz crystals, very easy to find. I mean, you can get them, pretty much anywhere on eBay. The band module crystals were a little hard to find. I had to actually go to DigiKey for a couple of them, and eBay for another one. But pretty much the rest of the components are very easy to find. I think probably the things that are getting in short supply are these SA602s or NE612s. They go by a variety of names. They're getting harder to find in the dip format. A lot of places are selling the surface mount. And obviously, I guess I could do a dip to surface mount conversion, but that would be a bit of a pain. So yeah, all in all, a fun build. I had a lot of fun with this. I hope this has been a useful series. I hope someone finds this series useful. That would be nice. And so at this point, I'll sign off for now, and I'll catch you later. Bye.